Muito obrigado, Roberto. Bom dia a todas, senhoras, bom dia, senhores. Antes de iniciar nossos trabalhos, nós gostaríamos de fazer um minuto de silêncio pelas vítimas de enchentes em Santa Catarina. Já são mais de 250 mil desabrigados, mais de 100 mortes, e pelas vítimas dos atentados terroristas em Mumbai, na Índia. Muito obrigado. Temos um dia cheio de palestras. Nós vamos começar pelo Dr. Richard, da IOM. Dr. Richard, por favor, à mesa. O senhor tem a sua palestra. Fique à vontade. Vamos começar.
Meet you. I would like to present formation of mineral resources in the South and Equatorial Atlantic Ocean. Please. As you know, in the 21st century, the global society faces a potential threat to sustainability of the natural environment and to quality of life on the earth. Therefore, rational activities of the humankind should be directed and ensuring civilization development aided by use of natural resources, but with a complete understanding of their limited and finite nature. As you know, International Geological Society and UNESCO proclaimed years period 2007-2009 year of the planet Earth. The initiative of Ministry of Mines and Energy, Geological Survey of Brazil, and the International Seabed Authority to convene this seminar is extremely timely and important. It's impossible, I hope you agree with me, it's impossible to discuss oceanic metallic deposits formation without considering first evolution of the Earth's geosystem and oceans and elucidated by global plate tectonic. The analysis showed that the differences between the Earth's ocean are a direct reflection of their stage-wise development. The differences in the structure and tectonic of the oceans are a result of differences in geodynamic processes taking place during evolution of the oceans. The comparative analysis that have been carried out and the relationship revealed indicate that in the author's opinion, formation of continental platforms and oceans was associated with cyclic remodeling of the Earth expressed as merging of blocks to form mega and supercontinents and disintegration thereof, as well as formation of ocean. In Chinese opinion, those processes take place within so-called supercontinental diastrophic Wilson cycle every 800 million years. These cycles involve consolidation of continental blocks, they break down, formation of the ocean, and their development and closure, which produce a new collision of blocks which are now continental platforms. the Earth's transformation in the Wilson diastrophic cycles to have proceeded at intervals 1.85, 105, and 0.25 billion years. Evolution of the litho and hydrosphere is tightly coupled with evolution of the bio and atmosphere, the coupling showing a number of relationships and feedbacks within the geosystem. The first diastrophic Wilson cycle, W1, involved emergence and consolidation of the Laurentia megacontinent. Thus, 1.85 billion years ago, the continental platform significantly expanded by the emerging Proterozoic crust surrounding the archaic craton nuclei, were consolidated to form the first megacontinent of Laurentia. North America with Greenland, Antarctica, Australia, and Siberia. The second Wilson cycle was 1.05 billion years, began after the Laurentian megacontinent accreted the cratons of Baltica, Africa, South America, and India to form a first Rodinia supercontinent. That event was characterized by increased magmatic and metamorphic activities expressed orogenic processes. Fusion of America with Gondwana, Alaska, and Greenland, about 200 million years, led to formation of the Pangea supercontinent, which correspond to the beginning of the last Wilson cycle, W3, the breakup of Pangea in the Triassic, triggered process leading to Pacific remodeling, including the closure of the Tethys Sea, the emergence of the north part of the Atlantic, opening of Indian Ocean, and formation of South Atlantic. Major stages of transformation of the ocean. In the present author's opinion, Gramberg's model of the origin and evolution of the Earth's ocean make it possible to identify age-related evolutionary changes in both the ocean and in the continental platform margins. Interlinking the process proceeding at each stage of evolution of the ocean facilitates exploration of process underpinning formation of mineral deposits, including oil, gas, and metals. The individual nature of each of the ocean is expressed geometrically and structurally by specificity of the geodynamic regime of their development. This is evidenced by different form of the type of divergent and convergent boundaries of the oceanic plate, continental markings, seismicity, volcanics, oceanic crust spreading rate, and within plate hydrothermal activity. Initial stages of the contemporary ocean coincides with geological periods corresponding to global events in reef generation. The Neoproterozoic in the Pacific, the Triassic in the Atlantic and Indian Ocean, and the Upper Cretaceous Paleogene in the Arctic Ocean. The global ocean rift megasystem can be divided into the following segments, differing in their spreading rates. Indo-Pacific, Indo-Atlantic, Indo-Mediterranean, and Arctic Gackel Ridge. You can see that global intraoceanic rift megasystem is clearly divided in rich segments of spreading zones converging at tri-junction nodes of the AAA type, Bouvet in South Atlantic, Rodriguez in the Indian Ocean, and Hess in the Eastern Pacific. Age of the ocean crust. Differentiation of the oceanic crust plates mirror age differences of the oceanic fundament. The young oceanic plate include the mid-ocean active ridges or rises from C1 magnetic anomaly to C4 and plate transform zone on slopes from C5 to C34. Parts of the plates which are characterized by normal polarity on non-spreading development, so-called a cratericals quiet zone, a time interval between C34 anomaly and the Mesozoic 1M1A from 83.5 Santonian to 116 million years ago Aptian. The old oceanic plates had been forming since the formation of the oceanic ridge system in the mid-Jurassic from 161 to 116. You can see age of the oceanic crust, young oceanic crust and old oceanic crust, old here, and this quiet zone, and this young oceanic crust. There you can see you can see change of the sea level, relative average level for the ocean was 135 meters. There is 0. Okay, please, next. It's commonly held that Atlantic dates back to the early Jurassic and Indian Ocean dates back to the late Jurassic, in association with the beginning of spreading processes. However, the fracture of the continental crust, its spread and submergence typical of rift stage of ocean formation took place in Triassic. Therefore, the geological age interval necessary for the formation of the contemporary Atlantic spans about 200 up to 250 million years, considering the Mesozoic age of the Atlantic, as well as its morphology, geological structure of the seafloor, composition and thickness of the sedimentary cover and ocean crust spreading rate. The Atlantic is regarded as staying at the major stage of evolution. Morphostructural analysis transfer fault system in the Atlantic demonstrate variation in their pattern and internal structure. Some of them show a simple structure expressed in the seafloor relief of a thin trench, occasionally very long. For example, Agulhas and Romanche. The major role in formation of ferromanganese oxide deposits, polymetallic nodules, and cobalt-rich crust is played by the seafloor relief, sources of components, structure and physicochemical properties of water column, depths of geochemical barriers, oxygen minimum zone, aragonite compensation depths, calcium compensation depths, and siliceous compensation depths, near bottom dynamics and surface productivity. We can find in the world ocean pre-generation, the generation mirroring variability of condition and the time of formation and correspond to individual episodes of ocean evolution and transformation. The crust are a direct manifestation of gradual subsidence of seamounts gyres. In the outer opinion, the existing data on the presence and distribution of cobalt-rich crust and their metal concentration, including those cobalt, manganese, and nickel, are not represented enough to assess the character of crust deposits. Hence, they are not really able enough for the assessment of prospecting amenability of individual areas. It is difficult to regard data obtained from 9 Valvis Ridge or 12 for Rio Grande sampling sites as sufficient. It has to be pointed out that the criteria recommended for prospectivity assessment, cobalt index, cobalt more than 0.5% and cobalt index more than 0.9%, crust abundance more than 50 kilograms per square meter, markedly limit a possibility of detecting highly prospective area in the Atlantic Ocean. I analyze all published data and taking into account number of sampling stations, cobalt index, cobalt, manganese, nickel, and thickness of this crust. It's very, very thin crust in Atlantic Ocean. Next, please. Areas recommended for prospecting of the potential cobalt-rich manganese crust in Atlantic Ocean for prospection can be Madeira, Sierra Leone, Guyana, Brazil, Valvis Ridge, and Rio Grande. For existing data, the most promising area recommended for prospection is Valvis Ridge. Thus, considering the general pattern of formation of various crust generations, the object listed, Madeira, Sierra Leone, Valvis, can be regarded as the most amenable to prospecting. The prospecting value of the area, metal concentration, and nature of crust distribution can only be assessed from the optimal sampling site grid set up based on 1 to 500,000 map charts aided by images provided by side-scan sonar and photoprofiling. Click, please. Click, please. 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 Click, please. Please click. Depths above 2005, area 111, cobalt index 091, and contents of cobalt very low. Next, please. Rio Grande, depths above 3,500 meters. Please, next. Valvis. Please. Okay, please. Please. Okay, please. Bathymetry, and now area above 2,500 meters. Next, please. This area, depths, cobalt index 1.41 and cobalt more than 50, 0.57, area 139 square kilometers. Please, next. Depths above 3,500 meters, a little bit larger. Okay. Distribution of hydrothermal cobalt-rich manganese crust in the Atlantic Ocean. This I show in this area. However, you can see that amount of sampling station is very, very low. Next, please. Hydrothermal massive sulfide ores in the Atlantic areas featuring the presence of massive polymetallic sulfides ores are associated with the Mid-Atlantic ridge spreading axis, particularly so its northern part, distinct by the occurrence of asymmetric rift valleys bordered by fracture slopes. The most promising area of massive sulfides or prospecting are nodal basins which frequently form trip junctions and intersection of transform faults at rifts. The highest concentration of hydrothermal vent sulfide deposits are found within the oceanic block situated between transoceanic fractures of Pico and 1520, Kurchatov, Lucky Strike, Oceanographer, Broken Spur, Tack, Snake Pit, Logachev. Please next. You can see map with the most promising area, Kurchatov, Lucky Strike, Oceanography, and concentration of metal. Next, please. Emergency and evolution of the Atlantic Ocean have been closely coupled with stages of the Earth's ocean transformation. According to the age-based typology, the Atlantic is a mature form distinguished by a slow spreading rates and the presence of passive margins, blocks of the oceanic crust separated by transoceanic fractures formed in the northern part and southern of the ocean under differing geodynamic regimes. Ferromanganese oxide deposits and accumulation of hydrothermal vent sulfides have formed in the Atlantic under the influence of environmental conditions that differ between northern and the southern part of the ocean, which is expressed different metal concentration. Knowledge on areas potentially amenable to prospecting for cobalt-rich crust and hydrothermal vent sulfide ores is still insufficient and requires further detailed exploration and research. Thank you very much for your attention.